video, we're going to learn on our next chapter, which is on number system. And before we go deeper, we need to know that there is two types of numbers in number system, which is non-positional and also positional. So our focus is mainly on positional, but let's take a look what is non-positional number system. So basically, non-positionals is using a symbols. Let's say 1 over here, and then 2, 3, and then we have 4, 5, and etc. So this is the symbol representing of the value, and it's regardless of its positions in the numbers. The symbols are simply added to find out the value of particular number, and it's quite difficult because you need to memorize of each symbols, because it is in symbols we need to memorize what symbols represent what numbers. And of course it's difficult to perform in arithmetic just as in the number system. So this is just overview on non-positionals. So the important part in our learnings in this subject is on the positionals on the number system, which is it's use only a few symbols, which is called as digits, and these symbols represent different value depend on the position they occupy in the number itself. So let's take a look deeper. Positions number system, which is the value of each digit is determined by the digit itself. The second one is the positions of the digit in the numbers, and the third one, the base of the number system. So what is the base? Base is the total number of digits in number system. So the maximum value of single digit is always equal to 1 less than value of the base. So what is this all about? Later on you will go deeper and understand what is this meaning. And this is just a representations of equations on how you're going to get the value depend on your base and also numbering. So over here, okay, we have basically on the positional number system. Normally, later on you will see what is the numbering system that we normally use, but this is the possibility, which is, let's say we have the base 2, 3, 4, 5, 8, 10, 16, and basically we can have all numbers as the base system. So binary is, of course we know in science, bi is 2, so it is binary, and the numericals is on 1 and 2 only. And then because it base 2, it's only have 2 digits. First digit is 0, and the second one is 1. The third one you will see that you will understand the flow. So for the third, which is try, science is referred to 3. So trinary, which is the numerical is 0, 1, and 2, because it's base 3, 1, 2, 3, you have 3 digits. And then for 4, which is quarter, as the science and also mathematics, which is quaternary, we have 0, 1, 2, 3, and then let's say we have octal over here, which is 8. We have 0, 1, 2, 3, 4, 5, 6, 7, and the total is basically 8 because it base 8. And then for the base 10, we have 0 until 9. So total is 10 base, 10 digit. And also 16, which is we call as hexadecimals. We have 0 until 9, which is 10 over here, and then A until F we have 6, total of 16. So why it is A, B until F? Because of course we cannot have 0 as representations of hexa number. That's why we call as A represented as 10, and then B as 11, C as 12, D as 13, E as 14, and lastly F as 15. So this is just the basic one on the positional number system. And over here, this is the common number system, and you're going to look into your mathematics subject, in also your computing also you will have a look on this, which is basically you use these decimals numbers, and then binary, octal, and hexadecimal. You need to know how to convert between these and each of this number system, and etc. So in decimals, decimal is basically base 10, and of course the symbols is from 0 to 9. So we have 10 digits as representations of basic tens or decimals. So second, we have binary, which is base 2, and the symbols digits is 0 and 1. And about octals, octal is base 8, and the symbols is 0 until 7, which is altogether 8 digits. And add symbols also. And then hexadecimals is the base 16, and the symbols is 0 until 9, and then followed by A until F. It's quite simple if you can memorize this basic understanding on the numbering system for each of the base system numbers, which is decimals, binary, octal, and hexadecimal. So let's have move to another, which is on the example. This is on the examples of base 10, but I think before that, okay, let's have a look into base 10. Over here, this is the examples of numbering system that you always look into. So let's say you have 4839.72, which is base 10. So before we go into what is these numbers, basically I want to share with you on where is my slide, basically over here on this. Sorry, I messed up the thing. So over here you can see that decimals numbers is a positional number system, and of course it has 10 symbols or 10 digits, as I already mentioned in previous slide. We have 0, 1, 2, 3, 4, 5 until 9, and it is of course base 10. If you calculate, we have 10 digits. The maximum values of single digits is 9. This is the maximum numbers of single digits, and one, which is I already mentioned in the previous slide, one less than values of the base, which is 10 minus 1, because less one digit, which is 9. So this is the maximum value of single digit. That is come over here if you look into our main slide over here. Where is it? Something here. Okay, in this slide. So if you can see that over here it's mentioned the maximum value of single digit is always equal to one less than the value of the base. So now you understand, right? If let's say you have base 10, so the maximum digits of value is 9, because it's minus 1 or less 1. So let's go back to our main slide, which is on the decimal. I don't know why I drag it down below. So over here we can see each positions of digit represent a specific power of the 10. So example, which is we have the first, we need to see where is the starting point of the number, which is starting on the dot over here, which is normally we can call point, or also a dot, of course. So we have, if we go to the left, we have the positive side, and then if we go to the right side, it is negative value. So for the left, first we have 10 to the power of 0, 10 to the power of 1, 10 to the power of 2, 3 until 9, or until 5, and etc. And then over here we have 10 to the power of negative 1, 10 to the power of negative 2, and 10 to the power of negative 3 until n. So this is how basically the examples of look like. And you need to know that normal daily, day to day, we use this past 10 numbering system. So this one is how about the example if we express the decimal 47. So how we get 47 value? We get basically, we have over here 47, and then we have over here like this one is 0. So this one is 10 to the power of 0, and then 10 to the power of 1. So what happened between here is you need to multiple. Over here you have 7, so you multiple 7 with 10 to the power of 0. 10 to the power of 0 is 1. So 10 to the power of 1 is 10. So 7 multiple 10, you get over here, 7 multiple 1, you get 7. 4 multiple to 10, you get 40. So now you will add 40, add 7, you get 47. So this is how you calculate in every singles of decimal value. So this is the table. Let me erase first. So over here you have the decimal value and also the positioning. So now we see the calculation part. The example, let's say we have 1024.68 base 10. So how we're going to measure is over here. We have 6, 8 for the negative side, which is starting from this point, and for 6 it is 10. You need to multiple, over here until this one. So you multiple 1, multiple 10 to the power of 3, and then this result you add 0 multiple 10 to the power of 2, you add 2 multiple 10 to the power of 1, add, and over here you add, and you will get the value. Same also, this one you already have the instruction how you get is basically this is referred to here, which is 1 multiple 10 to the power of 3. This one is here, this is here, and then this is here. So after that, you just add all the digits and you will get the answer. And over here there is exercise. I just give you I think you have also this exercise in your module, and also I will upload it and the module 2 also in your e-learning, so you can try by yourself on how you get that numbering. So on the binary number, so what is binary number? It is a positional number system which is only have 2 digits, 0 and 1. So here is the base 2, and then the maximum value of single digit is 1, which is 1 less than value 1. You can see over here the maximum is 1 because it's less 1 from the base. Each position's digit represent a specific power of the base 2. So this is how it's look like. You have the numericals, you have the name as binary, and then what is the base. Binary is quite simple, but you need to know also how the conversions part when you need to convert binary to decimal, decimal to the binary, binary to octal, hexadecimal, and etc. And how it's basically look like is you have this one is the middle one, and the point is starting from here, so to the right and then to the left. Left is positive side. This is mathematics, I think. This one is negative side, and you have all negative powers. This one is positive powers. So it starts from 2 to the power of 0, to the power of 1, to the power of 2, to the power of 3, and till the rest. Same goes to over your right, which is to the power of negative 1, to the power of negative 2, and etc. So this is on the positional value. And then about the binary word value and also decimal value over here, you're going to convert, which is you need to multiple what is numbering there, but this one is on the weight stage of the value. If let's say you have 1, this one is of course 1 times to the power of 0, you get 1, and then the answer should be 1. Let's say you have, because you have 0 and 1 only, so let's say you have 1, 0, you have the possibility of 1, over here is 0, and then this one is 1, 1, 0. What is basically 1, 0 is 0 times to the power of 0, and then this one is 1, you times or multiple with to the power of 1. To the power of 1 you can calculate by yourself, it is 2, and then to the power of 0 you get 1. So every single value or digit which is your power of 0, you will get 1. So you get over here 0 times 1, every single digit times 0 you get 0, and then over here 1 multiple of 2 you get 2. So what is 1, 0? You get over here, this is the added part, which is 2 add 0. It is not 20, but 2 plus 0 equal as 2 of the base 10. So if let's say you have 10 on over here, it should be binary, you will get 2 for the base decimals or also base 10. Same goes to over here. You can see if you have 1 for your binary, you get 1 for decimals. For decimals, if you have 1 0 for binary, you get decimal 2. Binary, you have 1 0 0, you get decimal 4. And then you have over here 1 0 0 0. Binary, you get 8 for decimal, and etc. You need to know how to calculate it using the simple method over here. Why the importance of binary? Why you need to learn binary? Binary in computing is very important because basically the computer itself is made up from several combinations of electronic devices and electronic components. So as for that, we can have only two states, which is on refer to 1 and off refer to 0. And all digital computer use this method. As let's say you have the data transfer, of course you will, let's say, typing in your words hello, but your understand is hello itself. You type HELLO, and then there will be a system in your computer will convert it into the 1010, which is binary. And then data from computer will convert into binary form. Computer understand only binary language, which is computer on a digital computer. And then the most thing that you need to know is further convert, because if let's say your output will be 1010, you will having the difficulty to understand what is basically about. So that's why after your computer process the binary form, there will be output on the decimal itself. So this is the examples on how you're going to get the decimals numbers or value from the binary numbers. So over here you can see basically how it's calculated, and please write it by your own. You can just print screen this video first and then try calculate it by your own how you will get. Of course you have your own calculator to just press and convert binary to decimal, binary to hexadecimal, and etc. But please remind yourself that in your final exam, in your test, in your assignment, and etc., you will need the step on how you get this answer. If let's say I give you these numbers and then you directly convert it into the answer, if let's say it is 10 marks, you get only 1 marks and you just lost 9 marks. Although let's say you write it already in a rough of paper, or you just direct convert it into calculator using your calculator, you lost 9 marks because you did not show your step how you get that answer. So the step is very important. So now is on the hexadecimals. Hexadecimals is spans 16. I think should be the first one is on octal. Let me check. where is my octal part? So I think I messed up my slide already, but it's okay. So over here, maybe we can just focus on hexadecimal first. Later on, I will show you the octal. Octal is basically base 8, but it is just a simple one, which is, you can see over here, it is base 8. So after this, I will show you the base 8. Now we go and take a look on the base 16 first, which is under hexadecimal. You can have a look that hexadecimal have 0 until 9 and then A until F, which is, I already mentioned before, that A is representing as 10, B as 11, C as 12, D as 16, until F is 15. So altogether you have 16 bits of also symbols of your hexadecimal numbering. So 16 possible symbols or digit. You have 0 until 9, you have also 8 until F. And this is representations of decimals, and then this is hexadecimal symbols. This is the important part, which is on the representations of decimal value into hexadecimal value. So over here you have a table also similar to our decimals, and then binary, and then also until the decimals we have hexadecimal, we have the table, of course. So it is the power of 16 to the power of -1 for the right, and then 16 to the -2, the power of 2 -2, and etc. So same goes to the left one. It is positive side, 16 to the power of 0, 16 to the power of 1 until the end. And so you have the examples of this, which is, I already mentioned. If you have, let's say I give you the example A216.D. So you need to notify that there is a point over here. So it start to the left and also right. Right is negative and then left is positive. And over here you have of course you have 16, because 16 is the best, the minus of 1, 16 the minus 16 the power of 0, 16 the power of 1, 16 the power of 2, and then 16 the power of 3. You need to multiply all of these values with the best below. So D, you will multiply to the 16 to the minus of 1, which is, you have basically 0.0625 for this one, and then you will get the answer after you multiples, and then same goes to here, and all the rest you will add. Similar step to like previous of decimal and also binary. So this is also another example, and I also provide with the step how you can get the decimals from hexadecimal. It's quite easy to convert by just pressing the calculator, but yes, I just remind you that you need to know how you calculate and convert it using a step, manual step. And then over here you have the examples of another expressions, which is 5 is 7.25 to F power of, also the base is 16. So how you get, I already showed you also the step. So these notes, I think you can also refer to your module. In your module also there is a lot other examples and explanations, and I also will upload extra notes refer to your numbering system. And how you convert from any base to decimal. So all summations of equations is value in decimal. So please take note that all examples in previous slide are converting into decimals number without a total. So you can calculate it by your own, of course. Calculate the value in decimal to those examples given here. So this one you will get the answer, but the previous one you need to calculate it or add it by yourself. So next, over here also there is another extra example that you can refer to. This is also another extra. You can have a look into it. How you get 3 to 0, 32, and etc. You know basically the tables that I provided, which is you need to have what kind of 2 to the power of -1, or let's say over here it's 2 to the power of 0 for binary, and then over here add to the power of -1, add 0. Over here will be positive 1, positive 1, until the rest is negative, and etc. So over here you have a simple deductions, which is under binary number. How you need to fill in the blank space basically. I don't want to show your answer. Please screenshot this page. I think in your module there is answer, but no, I think there is no answer. Let me check after this, but please try to use this template and fill it by your own self. How is basically the decimals and what is the answer for binary, and then you have decimal, what is in binary also, same goes to all. So this one, the solutions over here I don't want to show basically, and over here you can see that based on the answer that you have calculated in the table, select the correct answer below the best descriptions that deduce observations for A, B, and also C. What you're going to conclude. So an even number is for the C, and then A is the power of 2 is equivalent to the number of zeros in the binary representations, and also another one is B is a binary number is equal to 2x minus 1. So this table is basically you need to know and understand the correlation between binary and decimal. If you understand the basic, you can just straightly know what is the point of this ABC table. So this is just example on the previous which is about, let me jump straightly to our main focus. I think we need to stop for this slide because this is under your conversions. I don't want to touch more on the conversion, I need to make it as the next video because it's already too long. So we stop now, and I will make a next video on just referring our conversions of number system. We can have a look into our slide over here. Oh, before I forgot, let's take a look on our octal numbering. So we have decimal, we have binary, we need to have the octal. So over here we have the octal numbering, which is base 8, and on the octal we of course have, you can see over here, 0 until 7, which is 0 until 7, 0 1 2 3 until 7, which is all together add digits or add symbols. So the examples is like this table, similar to decimal, similar to binary, and also our hexadecimal, which is I already jumped from binary straightly to a hexadecimal before we go to the octal. So same also to the right we have negative, and also to the left we have positive. We have 8 to the power of negative 1 and to the power of negative 2. So what is the value we stated in these two tables? Same goes to the left one, which is 8 to the power of 0, you get 1, and etc. So this is the example the base 8 or octal. You can try, have a look, but there is no answer. You can just add it over here. So what is the point is I already show you the examples, which is you need to divide it to the right and to the left. From here you will multiple with 8 to the power of negative 1. You will multiple to the 8 to the power of negative 2. Same goes to here, you will start on 0, add to the power of 0, and then add to the power of 1, add to the power of 2, and lastly add to the power of 3. You have after you multiple all this number, you need to add all the value, and you will get answers similar to this step. Okay, I think just that for this numbering system. In next video I will show you on the how you're going to do the conversion on all this numbering system. So thank you for watching. I take your time too long, so I'm not going to have a long versions of video because it will occupy more time and your focus is lost, I think so. Okay, thank you for watching and have a good day.